want to ask is, okay, for example, we have this kind of sine function. What do you have any idea how to limit the value of sine function? Do you understand what I mean? No. So, well, okay. Uh, let us. Okay, I give simpler function. No more, not more simple, but more concrete. So as you can see, in example example 3, it is limit x approaching to 0 of function x cubic plus cos 5x divided by 10,000. So what happen if I replace 0 to infinity? What is the limit x approaching infinity of x cubic plus cos 5x divided by 10,000? Yep. The y.
It would result in the, I think, infinity plus something. So the result of the limit would like binary value as the infinity, I guess.
Yeah. Yes. So basically there is two function here. One is polynomial, the x cubic. Another one is trigonometry, cos 5x. The x cubic is approaching to what I mean is unbounded. So when the x become extremely large, the function also become extremely large. While the cos function is bounded, because doesn't matter whatever happen, even when x become infinity or minus infinity or 0 or approaching 0, the function cannot bigger than 1, right? So divided by 10,000, the magnitude of the function cannot be bigger than 1 over 10,000. So basically that's the game of the limit. You must try to limit a function so it's become bounded, some kind of bounded. If we cannot limit the function, then when the limit of x approaching that kind of value, then we say the limit is approaching infinity. But approaching infinity or become zero, or the limit has any value, is not really problematic. The problem is when the value become undefined. Do you still remember when the value is become undefined? One is dense, but that's not what I mean. What I mean is when the value is become 0 divided by 0, like this one, sine x over x. Another case is when the value is 0 times infinity. That's kind of stuff. Have you learned that in the high school? Yes? No? The 0 divided by 0. Okay. So I think for the limit of trigonometry function, the only thing that you must memorize is this kind of function, limit of x approaching to 0, sine x over x. It can be sine 5x over 5x, or whatever x divided by x, but the answer will be always 1. So for example, if I replace that this one with limit x to the 0 or sine x over 5x, its value become what? One over 5, yes, because that's the same as sine x over x times x over 5. Sine x over x become 1, and x over 5x become 1 over 5. So 1 times 1 over 5, we get 1 over 5. And the same with the tangent. the tangent one also become you, because the tangent is basically sine over cos. So the sorry, cos usually not problematic, but the sine, well, you just become sine over x, and yes, we can solve that. And it can be, for example, limit x over sine x, also not a problem because it's still one. Okay. I think this kind of question is easy, right? No, no problem. You just factorize, and you can have the answer just like what we did in the previous session. I think basically limit is easy before we reach delta epsilon problem. Then when we reach delta epsilon problem, the limits is become the I think the hardest subject in the calculus. So you can be relaxed for now. Left and right side. Delta epsilon. Have Professor Iman taught something about delta epsilon?
Not yet. We haven't studied about this.
Thank God. That's the hard part. Okay, let us see. That's much. Sorry. Okay, as I said before, from the previous year, usually the mid exam in the calculus is following this kind of type of question in the review part in the books. So there are some conceptual question. But I think you guys did not learn about squeeze theorem yet, right?
Squeeze theorem.
Yes.
We learned about that already.
Oh, you have learned it. Okay, no problem. I think just ensure that you can find a function that can squeeze one value from above and below that point, and make sure that in that point the top function and the bottom function has the same value. Then your life will be easy. Intermediate value theorem. No, I think. Asymptotes.
Yes, we learned about that already.
Okay. So, okay, y equals tangent x. Remember where is the the asymptote?
The pi over 2 and minus pi over 2 is vertical asymptote.
Vertical, horizontal?
Vertical.
Yes, vertical. But it is not only pi over 2 or minus pi over 2.
It's n pi over 2, right? Like it's pi over 2 and like
Yes,
n
n
so on.
plus minus pi over 2 when n is integer, whatever integer, or for all integer. Oh, now sine x, has it, sorry, is it has any asymptotes?
It has horizontal asymptote.
Okay. Have you learned about diagonal asymptote?
I think not yet, like in hyperbola or what? Not yet.
Okay, make sure you understand that. Usually there is no true and false question, but there can be. You didn't learn about differentiable, right? Yet. Have you?
Not yet.
Just only continuous.
Yes.
No problem about continuity, right?
I'm good. Like let's ask Arthur also.
Sorry?
Like I'm good with it. Like let's ask Arthur also.
Oh, okay. Okay, if the function is like number 21, what is the asymptote of the curve? Hey, that's one of the asymptote, but not only that. So now I ask you, when x approaching infinity, what is the value of y? Y.
Like it would result in the value within -1 to 1 divided by infinity. So like the value would approach zero eventually.
Okay, good. So what I want to say is uh, sorry, what 1 minute? One no. So I want to ensure that you guys understand this that this function is always be positive, right? Do you get it? Yes. Yeah. Okay. Because it's quadratic function. It is cos x divided by x, and you take square of. I'm sorry because there is a problem in technical problem in my electrical pen. Oh, you cannot see. Wait a minute. Okay, later. But the function is approaching infinity when 0, and then the falling down, but little bit up and down and up and down, because the cosinus x is a periodic function, right? But the amplitude becomes smaller and smaller and smaller and smaller. So basically, the asymptotes of the curve is 1 over x squared. Do you understand what I mean? So this function is always smaller, or we can say it is bounded by the function 1 over x squared. Can you imagine that? Can you get it? Yeah. So in this function, the asymptote is, yes, there is one vertical asymptote. Another asymptote is 1 over x squared that limit the function. Precise definition of limit. You have learned that, right?
Precise definition, right?
Oh, in the video.
Yes, he uploaded the video for us. Yes.
No problem, right? It's just long. It's just like we know the answer, but you still need to follow the procedure. Yes, that's I don't think that's difficult. That's maybe not nice. Yeah, that's life. Okay, finding limit. You have no problem, right? Oh, cats, crowd, baby brown, baby blue. Number 56. This is a floor function, right? Or or I'm wrong. Eh, You, you have learned about the scaling function and floor function, right? Hello? Anybody? Okay, no problem. Uh, so scaling function, and then we have floor function. I think nobody of us has English as our first language, but everybody understands sailing, right? Sailing is the top of the building, the top of the room, and floor is the bottom of the room. So, for example, the sailing function of 2.25 is any answer? Do you know that? No? Okay. So the sailing, yes, 3. So we just make it a non-integer number become integer. The sailing is going up, floor is going down. That's it. So the floor function of 2.225 is 2. That's that's all you need about sailing and floor. So in this case, I'm not sure it is sailing or floor, but let's say assume it's sailing, then I think that's easy. It's just becomes 0 and when the number is discontinuous. But the point is, sailing and floor function is one of the function that can be asked in the calculus exam. So you guys need to know that. Okay, we have learned about this question before. Okay. I think number 2 is, well, maybe you can try the number 2. And let's say I give 5 minutes, and after that I give you the answer. But if you have finished it, you can say to me and we can discuss that. Okay. So, so well, basically it's easy. Everything divided by 0 should become infinity, right? But it is not infinity. It is 1. So we must change this thing into 0/0 form or infinity by infinity if you can. But because the bottom side has become 0 and the top part also becomes 0. So the square root of ax plus b must be 2. So x plus b must be 4. So B is obviously 4. And A what is A? What do you think A should be? Any clue about A? No. -4. Interesting. I think A can be any number, any real number, because it's the X part is quite irrelevant for us. So A is any real number, I think. Well, yeah, I'm quite sure about that. So not only -4, it's can be everything. Oh yeah, so that's this kind of function is what I call sailing function before. Here they call it greatest integer function. But it's the same. Number 7. What is the domain and range of this function? What do you think? What is the domain? No? No clue? Yep. All integer except 0. Well, not really. Sorry. All real number except 0. You see the difference, right? I mean the domain. The domain is all real number except 0. And how about the range? What do you think is the range? No, not this is from 0 to 1. No. No, not all the not all the real number. Okay, I give you a clue. So for example, if the x is 5.0000001, what will we get? If x equal to, hello, can you hear me? Okay, what will you get if the x is 5.00001? Now the function become 5.0000001 divided by 6, because the denominator becomes 6, right? Yes. So what we get is the smallest value of the range is n minus 1 over n, which is the same as 1 minus 1 over n. And sorry, Palis, I think you are right, because here the smallest one is when n is big 1. So yeah, it can be from 0 to 1. So the smallest number is approaching 0. The range is from 0 to 1. But okay, bye bye. Thank you, Helen. And I think yes, sure, you can leave. Thank you. I think that's it from me. Do you have any question? If not, I think that's all for today. Thank you very much. See you later. Bye bye. Bye bye. Thank you.